Good morning, students. Let's proceed our chapter motion, and today we will study a very important topic, that is equation of motion by graphical method. I have taught you derivation of equation of motion of uniformly accelerated bodies. Today, how this equation of motion is derived by graphical method. So students, for this purpose, first of all, we have to draw the graph that I have shown you, and that graph should be of velocity and time. So I have drawn velocity and time graph. This position is O, that is your origin, and for this case we are not assuming that body starts from original position, that means at rest. In this case, let us assume that the body start moving with some initial velocity u. That means OA is equal to u. So body is moving with some initial velocity, that is OA, and as it starts moving from position A and comes to rest at position B. So here the body stop moving. So students, previous class we have seen that slope of velocity time graph shows acceleration. So this is AB is the slope. Here AB from of this graph we have got this as slope, and this slope is nothing but acceleration. This is A. So students, here what we are doing, now we have to find the relation of this AB with x-axis as well as with y-axis. Our x-axis is time and y-axis is velocity. So how we will relate this acceleration, means AB, to time axis as well as velocity, that is y-axis. Students, one thing you always remember, that whenever we are going to relate anything with x-axis and y-axis, then we are dropping perpendicular. That means it should be related to time axis. So what we will do? We drop one perpendicular line, say this, from B, this is B, to on time T. So we have dropped one perpendicular, we have got it. Now this acceleration, when we relate with y-axis, that is velocity axis, then what we are doing? We are just relating this one as, just see, again one perpendicular line on y-axis, this perpendicular line on y-axis. So with whom we have to relate? We have to draw perpendicular line on that axis. We have got these two line. Now students, one more I am just doing, because body starts moving from this position, that is A. So body starts moving at this position A, one perpendicular is dropped on, this is B and this is D. This is C. I have named C, D. So AC is perpendicular that has been dropped on BC. So students, OA, what we are getting? OA is nothing but initial velocity. You know U is initial velocity. Initial velocity. So we have got OA is U. At the same time, you are saying that OA is parallel to CD, and so CD is also U, that is initial velocity. Okay. Then here I am naming E. OE, now try to understand. OE is parallel to BD, is parallel to BD, and students, we know OE is velocity, that is final velocity. So BD, this total we have final velocity V, so we are having V. We have got this one V. Now AC is parallel to OD, AC is parallel to OD, and this AC and OD. OD is time axis, so let us take as a T, time. So here also we are taking as a T, time. So this is time axis, both AC and OD parallel to each other, and that is time axis. So this is the description of the graph from which we are going to derive equation of motion. Then you will think that miss, this equation of motion, yes, it is nothing but relationship between initial velocity, final velocity, acceleration, time, distance covered, means when body moves, body is in motion, whatever the different physical quantities are there, we are relating among themselves, and by relating this, we are finding out the three equation of. So students, one more thing we are leaving, that is BD. We have got BD. We don't know total BD, and we know that total BD is nothing but V. Then what will be CD? Here also CD I have shown you, that is U. So for this, if I will write BD is equal to here you will see CD, sorry, this one not BD. We don't have BC. We have to find out BC. So what we are writing? BC, this BC is equal to, may I write? BD minus CD. So what is BD? BD is V minus CD is U. So what we have got BC, that is V minus U, only one was remaining and rest we all have. So student, let's start now equation of motion. So first equation of motion is V is equal to U plus AT. How we will find out? Once I have taught you that whenever we are deriving the equation, first you introduce all the terms. So students, please introduce all the terms. So for this case, what we will do, let a body starts moving. Let a body starts moving with initial velocity, velocity U. After certain time t, it reaches its final velocity. Final velocity V, having acceleration A. So like this we have introduced. So you see, we have V, we have U, we have A, we have T, which is coming in first equation of motion. So how to start this again? We know acceleration AB, we have got from this motion, acceleration AB. AB we can indicate it by A. Students, you are remembering definition of acceleration, that is rate of change of velocity. So I am writing rate of change in velocity velocity. Rate, again I am reminding you, any physical quantity that is divided by time. So here change in velocity, what you are getting? Final velocity minus initial velocity by time. So here final velocity is v minus initial velocity is u by time is t. So this you have done, but when we are doing graphically, then students, what we will do? Just see. From the triangle, yes, I am writing this one. From the triangle, this is right angle triangle. So from triangle ABC, we have AB is equal to, we can write this one as perpendicular by base. So this is BC by AC. This is students graphically. So AB, this is AB is equal to BC by AC. What is BC? Just now I have shown you here. BC is V minus U, that is BD minus CD. So here I am writing BD minus CD by AC. Directly I am writing. Now you put what it indicates. BD minus CD is your V minus U. So students, now I am writing directly V minus U by AC. AC is nothing but, see here it indicates time. So directly I am writing time, and AB is what? Acceleration. So now you solve this. You will get AT is equal to V minus U. Therefore, V is equal to U plus AT. So students, you see, first equation we have derived, and that derivation is nothing but that is graphically we have derived. So you have seen from first equation of motion what conclusion we have got? We have got the conclusion is velocity time relation. So first equation of motion giving us velocity time relation. So students, come for second equation of motion. So in second equation of motion, we know S is equal to ut plus half at square. Again students, let's begin. We have to introduce all the terms related to this. So how you will introduce? Let a body starts moving with initial velocity u, and after certain time t, it covers distance s. With acceleration a. So students, you see here we have got u, t, s, a. In equation also we have u, t, s, a. So we have introduced all the terms. Now let's start. How you will start? Body is moving. So body starts moving from O, A, B. At B, it stops. So, what is the total area covered by the body? Here we are finding total area covered by the body. Then you will think that, miss, why we are finding out area? So if I will say you that you please cover whole area of the school and then come to me and give me response that yes, miss, we have completed. Then from where you will start, where you will end? Yes, you will start from the gate. Then where you will go? You will first go in vice principal office, or you will go in our first building, office building, or you will start from principal's that building, or you will start from girls club. From where you will start? So it's better to cover the distance of that building. If you will cover the whole distance of that building, that means naturally you will cover the whole area of that building. So here also, in our whole of the motion, the area covered by the body is OABD. So students, OABD. That means area of trapezium. Area of trapezium. Trapezium. Now, area of trapezium is this one. You know what is the area of trapezium? So, in this case, you see, this trapezium OABD is divided in two parts. Area of triangle ABC and area of rectangle OACD. So here I am writing area of triangle ABC plus area of rectangle OACD. Two, we are getting two shapes. Now students, you are knowing area of triangle, half base into altitude, half base into altitude plus area of rectangle, length into breadth. Length I am writing OD and breadth I am writing OA. So OD into OA. Now this one, how you will write it? I hope you are able to see this. Half. Now what is this distance? Total area covered. That means this is nothing but total distance covered. Total distance covered. Total area is OABD. So total distance directly I am writing, that is S. So here S is equal to half. Base is OD, that means time. Base is here base I am writing OD into altitude is BC. So here BC plus OD is time T into OA, and OA is U. So you have got half OD again time T. Now students, BC. We have calculated BC is BD minus CD. So V minus U. Directly I am writing V minus U plus UT. So from the first equation of motion, now students, I am wrapping first part. Then only we will able to do this. See this. Up to here we have done. Now I am starting from here. S is equal to half T V minus U. From first equation of motion, put the value of V is equal to U plus AT. So V U plus AT minus U plus UT. So U and U cancelled. So what you have got? UT plus half at into t, at square, so it is derived. So students, what conclusion we are getting from second equation of motion? We are getting that it represents position, time relation. It gives us position time relation. So from second equation of motion we are getting position time relation. And so you see this for third equation how we are deriving. Again it's very easy. V square minus u square is equal to 2as. Again as we have derived in second equation, we are having s. What is the total distance covered? What is this total distance? We can write total distance is equal to total area under which OABD. Total area under OABD. That is our trapezium. So again OABD, students who are knowing area of trapezium, that is half sum of the parallel sides into distance between them. So students, how we will do this? Half sum of the parallel side is your OA plus BD into distance between them is AC. So directly I am writing AC. Here half OA is nothing but U plus BD is V into AC is T. From first equation of motion, V is equal to U plus AT. We have T is equal to V minus U by A. So what we are getting? Half U plus V minus U by A. So S is equal to what we are getting? 2AS is equal to A plus B into A minus B, A square minus B square. So students, we have got the third equation that is derived. That is third equation of motion, and this third equation of motion shows us position, velocity relation. So today up to here it's very important for standard 9 as well as standard 11, and next class I think we are just remaining with our uniform circular motion, that we will do our next class. So up to here you please practice.